Okay. So after testing this, I learned this part's useless. I learned that it could use that this could be bigger. And I learned that this could be wider. I also said while I was testing it that I was wanting to use it not this way. I was wanting to use it this way by having this be the upright direction. But the two issues with doing that, are there's no room for the scoop to go inside of anything if I do that. And I just habitually learned to prefer to use it this way. And I did actually end up using this. Actually, I was cutting potatoes into cubes for soup, and I was doing it while watching TV, so I was doing it not in the kitchen, and I was doing it on a baking sheet which has a lip on it, so I couldn't just slide the potatoes off of the thing into the bowl. So I actually used this to scoop up the potatoes and put them in the bowl where I was putting the potatoes. And it worked fairly well. But this right here, that there chamfer could use some work. So I'm gonna go ahead and change. Let's see what happens if okay. I'm gonna go ahead and move the end of the thing, of the design, until it gets back to okay, that's a copy. That's a mirror, which means that this. Okay. The sketch I'm gonna keep. Everything from here to here, I'm gonna go ahead and just delete that. And then I'm going to change everything else from up here. So there are two things I want to do primarily. I want to make a better scoop shape. Right? I still have this sketch here, so I can still make a better scoop shape. And I want to make the tongs wider. But then a thing I also want to do is I want to design a new scoop shape from scratch that I can insert the tongs into, so that I don't have to keep reprinting the entire thing over and over and over, and I can just reprint the scoops every time I have a new test for the scoops, because I'm pretty sure the tongs are done, right? The tong part is the easiest part, I believe, of the two parts. I'm pretty sure that the design for the tongs are done. So I'm going to go back into the sketch for the tongs, which was here. And I'm going to make that bigger. And I'm going to eyeball what 90 looks like real quick. And then I'm going to eyeball. No, I'm going to have to go get the actual tong scoops. Hang on, I'm going to have to leave for a second. better not set the dang power button. Okay, let's see. 90 is that. This would look better. So if I measure what the tongs look like here. That's like 130. So pretty darn wide. I'm going to make them 120. Fail to solve. Fail to solve. Please delete or modify one of the following constraints or dimensions. Is there an angle somewhere? You know what? I think it's these constraints here. I don't need this thing. Nope. Failed to solve. Please delete or modify one of the following constraints or dimensions. Okay. Chia, you're dangerously close to the power button there. What happens if I... Okay, everything's just moving back and forth. Okay, well, in that case, I'm going to go ahead and Control-Z everything. Okay, now I can't even save anything anymore because I didn't make any changes. So, instead of doing that, I'm just going to copy what I did before. I hate doing that, but okay. So, I'm going to go back into this sketch here. I'm going to take a measurement real quick. 20.4. Okay. I'll start a sketch here. I'm going to get rid of all the bodies. But not in a murdery kind of way. Okay. That was 250, right? Yeah, it was 250. Okay. Then this is going to be 60, because that's going to be 120 divided by 2. It was about 130 with what I measured, but I'm going to bring it down to 120 because I had an idea for a different shape of scoop, which is why which is part of why I'm designing the thing the way I'm designing it. Bring back the sketch again. What was it? Sketch 8? Yeah. From this tip to the very outside. Okay. Yeah. So now I'm gonna put a line here. Gonna mirror it. And I'm gonna measure this and see what that is. 27 degrees. Okay. That's fine. Because I can't change that. That's going to be driven by those two distances. But what I could have done is made it 20 again. Right? I could have made that 20 degrees, but that'll make that longer. And that is 340, which I cannot do. So, yeah. Because 340 is too big for the build plate. Now I'm going to go ahead and offset this by 4. Select this as well. Put these there. Draw a line. Put 3 circles on it. Midpoint, endpoint, endpoint. All 5. Offset by 1.6. Put this one there. Move them in. Put it on the line. Put that there. And then find the extrude that created this. Is that it? Yes. That was 20. Okay. So make this 20 tall. Then make a midplane between these 2 planes. I can get rid of this one. Start a sketch here. I believe that was 2 or 2.4. I think 2.4. And these are equal. Okay, extrude this to there. No, I can't do the fillet yet. Mirror this. Now I can do the fillet. Or not the fillet, the chamfer. Whatever. Also, everyone else in the world calls them fillets. But when I was in high school, my teacher called them fillets, so that's how I learned how to say it. 2.399999. Okay. It's so weird that it can't go 2.4, but it can go 2.39999999. I'll just do 2.3. Alright. Now I'm going to create a sketch here. And now I'm going to bring up... Was it this one? Yes, it was this one. Sketch 15. And I'm going to actually not do that. I'm going to bring up sketch 15 and measure things. What do I need to measure? I think I need to measure this. So that's 14.5. And I need to measure this, which is 16.25. And I need to measure from here to here, which is 52.5. All right. So now I'll start a sketch here. Show dimensions so I can reference it. 15. No. 30. Because the radius is half the diameter. Offset of 2.4. There's the... Okay, this is parallel to this, and is tangent to that. Okay, so now... I can only move them this way. Can I make them parallel to this? Yes, I can. Okay, good. I don't want to do that quite yet, but I probably should actually, so I'm going to go ahead and do that. Okay. I'm going to put a point where they intersect here. Actually, no, that's not correct. I just need to make this. I believe it was 52.5. Yes, it was 52.5. So basically, the idea is, on this one, I'm gonna turn this scoop sideways. Right, and so the idea there, that's a construction line. The idea there would be that what would the idea be again? The idea there would be that I have more space, right, to I can increase the space inside the cavity there by just making it longer, if it needs to be longer. Okay. What was this? Okay, it's parallel, it's perpendicular to this one, that's good. Okay, and then I'm going to go ahead and mirror this. On this line. And extend this line. And I might actually make this collinear with this for now. And then I'll delete the collinear. Right? Yeah, actually, I'm going to make that a distance. It's going to be a 1/4 of a millimeter. And then what I am going to do is I'm going to make this collinear with this. And then that distance is going to be 1/4 of a millimeter plus 2.4 millimeters. And then this will go to, can I bring it down? Okay. Okay, cool. And then this here will be the same size, 2.65 it says. All right. And then I'm going to go ahead and extrude all of the stuff. It's going to be two-sided. Distance 1 is going to be to this plane. Oh no, wait, not joined, new body. And then distance 2, okay, I gotta measure this actually. No, I don't need to measure that, that's 20. Oh. There. That's gonna be 4.5 inches minus 20 millimeters. Can I do that? I don't know if I can do that. Something happened. And then I'm going to change this to 22.65. New body. Now the bodies are body 9 and body 10. And then to be lazy, I'm only going to design this body once. And I'm going to go ahead and mirror it real quick. Just for visualizations. That looks so dumb. Alright, and then, oh, wait a minute. Oh, I don't think I can design it just once. No, I can't design it just once because this here doesn't have the correct size to fit inside a fry cup. That changes the geometry of everything. But this is really funny. Anyways. I'm gonna go Control Z on that because I don't actually need to yet. Make a sketch here and project all of these faces. Okay. Holy moly. Oh, okay. This is gonna be annoying. Could not. Okay. Okay, can I, what happens if I select all these? Can I offset? Okay. Well, I'll just do it the hard way. This is vertical. And I'll just... make sure everything is a 1/4 millimeter away. Gotta make things parallel. I gotta make these parallel. Okay. Now I can... There we go. Okay. I forgot to measure how far that was going. Okay. Yeah. Okie dokie. Bring out, not this one, this one. Start at an offset of 2.65. And extent goes to here. Okay, there. And then just because I can, this makes absolutely no sense. This makes absolutely no sense. Why isn't it able to go all the frickin' way? 10 is too far. 9.5 is not far enough, is too far. Okay, that'll work. That'll make it less likely to break there, but... Okay, so now if I mirror this body... Then I pick a side to be the front side, or the me-facing side. That'll be this side. Can I just cut this away? No? Okay. Make a line from here to here, and from here to here, and put, I don't know, from here to there. Cut this out. Down to there. Bring the sketch back so I can make a plane. Here. I'm going to project this. There. The issue with that type of design is that if I bring back this, the issue with that is that only this side can scoop anything and this side can't. So I guess I'll have to keep it like this, right? The reason why this exists in the real fry scoop, right? It's there in the real fry scoop. The reason for that is so that the fries can fall away if they can't fall directly into the fry cup, right? Because the fry cup has only so much space in it. Because if you could put them all in every single fry cup, there would be, you'd be selling too many fries, and also you wouldn't be able to get a consistent amount of fries in there. I mean, you could, but I'm gonna have to go ahead and suppress this. And I'm gonna have to go ahead and just let them fall out afterwards, right? Instead of the fries falling out as I put them in the fry cup, they can fall out afterwards. So that's this scoop design, right? So yeah, that's this scoop design. Now I'm gonna go ahead and name these. Scoop A1. Scoop A2. I don't know. I have to go back into this. No, not this one. This one? Not this one. This one. Okay. The reason it has to be 45 inches in total, or 4.5 inches in total, is because I took some measurements of fry baskets, and that's how big the fry baskets that are at work. And I think they're a little bit shorter than or a little bit skinnier than the one I have here at home with me, but actually I can test that real quick. Tongs with scoop. The distance is actually about the same. Actually, the one I have here at home is a little skinnier, so I'm actually going to go ahead and change that again. Nope. To just 4. I'm going to lop off a 1/2 inch there. And then okay. I can probably afford another 1/4 inch of height. Yeah, now it's a little bit bigger. So make it 1/8 of an inch. Alright. Now I'm just going to get rid of all these sketches that I don't really care for. Sketch 8 I do care for, actually. Not 8. Not that one. Not that one. Not that one. 14? 15. Yeah, sketch 15 I care for. Okay. And then I will rename this to Tongs, because everything else got renamed so that Tongs is available as a name. And then I will make a sketch here, get rid of the 2 scoops, and I will go and do this one again, essentially, but make the changes that I said I was going to make. So okay. And then I'm going to get rid of the scoop and the tongs with scoop. Okay. So then it was 15. No, it was 30 because 30 is the diameter of 15. Offset this by 2.4. And then make this tangent, make this perpendicular to this, and then make this 52 divided by 4 or divided by 2 actually. No, 52 divided by 4 plus 52 divided by 2 then divide that by 2. Okay. 19.688. 60, yeah, a little bit bigger. This will be parallel to this. And then this will also be parallel to this and be distance away from it at 1/4 of a millimeter, because I'm going to do the same thing and add the little and then this is going to be, for now, it's going to be a construction line, as will this. What was this for? No, this wasn't a construction line. And parallel. Okay, so I said that I was going to round this off, but it might be better to just make it even sharper. I don't know. I don't know what's better. So I might have to just do both, which is going to be annoying, but yeah. Then I guess I'm just going to go ahead and sketch is over constrained. Perpendicular. What's this parallel to? It doesn't look parallel to anything. I'm gonna make sure nothing snaps to anything so I can put the constraints myself. There we go. This one is a construction line, and it's going to be collinear with this. And then .65, 2.65, just gonna make that 10 since I can. Okay, extrude. I'll start off with the rounded bit. Two sides. First distance is 4.125 inches minus 22.65 millimeters. And new body. Alright, make a sketch here. Do all that projecting crap. Go ahead, delete that one, and then make it a construction. Get rid of the tongs. Okay. This is going to be horizontal. These are going to be parallel. Now I should be able to put the dimensions. Delete that one. And I should be able to cut that out. That's weird. Why did I have to select it twice? Oh, because those... Okay. So that would be 10, I believe. Minus 10. Yeah. And then bring back the sketch. And cut away all this bit. Start offset 2.65. All the way to here. I don't know if I can chamfer this. Okay. I guess I can. Start a sketch here. Go ahead and project all this geometry. That should get it done. Put a line on the very outermost point here. And then connect it here. And just eyeball it. Oh, the plane's gone because I used it. mirror this body on this plane. Bring back the tongs, just so that I know what it looks like. Cool. And then bring back these. Okay, these I'm gonna print vertically. This I'm gonna print maybe also vertically. I don't know. Okay, and then if I'm looking at it this way, this one's the left. Scoop B left. Scoop B right. And then I guess I'll do the same thing with these. Alright. I don't know what else to call these scoop designs, but yeah. And then after this, I can test and see a couple of things. I mean, I've essentially made modular tongs here, right? If this works, I've essentially made modular tongs. And that would be pretty funny, because what that would mean is I could design any old head here that I want to do any old thing that I want. So, yeah. Oh! Oh, yeah. Mirror happens. This extrude happens. This extrude. This extrude. If I exclude that, okay. Now what? Okay. Gotta zoom way the heck in here. And put a line there. And whatever. That's probably gonna be too thin for the slicer to notice anyways. Okay, I should probably come up with a better name than Scoop A and Scoop B. So something I noticed is that because this one has a difference on it, right? On the two pieces, that means it's got a handedness, right? Like, if this is the me facing side, then I'm using it with my right hand. And if someone were to use this with their left hand, this would be the them facing side. Because it's got a handedness to it. So I could call it handed left and right and unhanded left and right. I don't like that. Oh, I've got it. This is a closed scoop, and this is an open scoop, because when they're fully together, there's a gap here on this scoop design that doesn't exist on this scoop design. Okay. Okay, so get rid of the A, and then put closed. And this one, closed. And this one, open. And this one, open. There. And the reason I like open and closed, and the reason I put them in the front, is because on the printer, when it's reading the files, if I have names that start with the same, if I have names that start with the same thing, right, then it's going to take me forever to read the whole thing, because the printer doesn't have much space on its screen to read the whole file name, so the file name scrolls across the screen. So actually what I'll do is I'll take the left and right, put them before scoop. Right, so that I can just look at, actually I can just look until I see the first letter of the second word. There. So that's that. And if I decide that this, oh, you know what? Hang on. Let me kill two birds with one stone here. There. Okay, so what I did there was the closed scoop has a rounded edge and the open scoop has a sharp edge. And I'm going to see what works better for scraping the bottom of the thing. But if I decide that the closed scoop works better than the open scoop, then I'm gonna have to come up with some way of angling inwards the shape of it. the reason being, if the closed scoop works better than the open scoop, then I might as well take advantage of the fact that I can have all the space I want going this way, right? But it still has to fit inside the fry cup, so the bottom here would have to be like, say, this long, and then the top would have to stay this long, right? If I decide that. So that's just a little curiosity. So now I'll just go ahead and save everything. Wait, not the tongs. I have to round off these edges here real quick. What was it, like 5? Make it 4. Okay. Now I can save it. Yes, replace it. Save. Right scoop. Yes, left scoop. Save. Okay. Now I'll save here. Yes. Okay. So I don't know what I'll decide is better, but if I decide that this is better, I'm gonna continue on with... Anyways. After this, if one of these designs does work and I decide to pick one, right, I'll start experimenting around with the different angles of these different slots. And I think I'm just going to go with slots. I might design a slot that I can rotate for testing, and then a static slot, you know, static, and then a immovable slot for the final design. But that's a little too much for now, so I'll stop here. I'll print out all 5 of these pieces. There are 5 pieces. 1, 2, 3. Yeah, I'll print out these 5 pieces here, and then I'll see how well they work. Okay. I've got these printed more or less. This one, was it this one? Yeah, this... Or was it this one? One of these failed. This one failed. It slid off of the build plate in the middle of the night, so I woke up to this much and a bunch of spaghetti. So I decided to just stop this one when it got approximately equal in height to this one, because the top part isn't really a concern here. It just needs to be long enough to go past the tongs, and of course it's long enough to go past the tongs, so the top part isn't really what's being tested. Not really. What's mostly being tested is the idea for the shape of the scoop, right? So I've got these fries, and I've got these cups, and I'm going to see how well these scoops pick up these fries, and how well I can scoop them into the cups. So I'm going to start off with these. I did test out how these fit in there, and let's see. There, these are all the way in. And that could be a problem, right? So if I choose this shape, right, I'm gonna have to I'm gonna have to make this side smaller than this side, right? So that there's room for it to, if I push this up, right, so that there's room for it to go like that. And I went ahead and pushed this up, so I'm gonna go ahead and test it like this. So, actually no, I'm gonna push it back down and test it. That was interesting. And that worked nicely. So what I did was, because these got grabbed like that, I kind of just let them fall into it. But that would take some practice, right? I'm gonna go a couple more times. I'm gonna try it from this angle. I'm gonna hold it the correct way this time. See, I want to hold it at this angle. That's the thing. What happens? Can I do this? All right. I don't like that it's grabbing them the way that it's grabbing them. I'm gonna push one of these out. That, I pushed that all the way out. Okay, I'm gonna push it out a little bit. And see, let's see. Actually, no, I'm gonna push this one out because it's the right one, right? And I'm gonna try and scoop with the right one. Yeah, there we go. So I'm gonna try and scoop that up and grab these. Now I've got some on the edge here, and I can kind of fit it in, right? And it's pouring them into here, but I don't like how it's grabbing them, right? Because part of the issue, I mean, the biggest issue is that when you use tongs, you can't get many fries at once, right? And then you have to like, takes like 3-4 scoops of tongs to get what you could get with one fry scoop, you know? So at least this is doing that. Right, but one issue that I really would have liked to solve that I don't know if I can is that it's hard to fit, it's hard to get them into the fry cup initially, you know? Anyways, I think that's about it for this one that I can think of. So now I'm gonna go ahead and do this one. It's in, and that's in. And these ones kind of have this thing where like they don't want to be at the same, they're supposed to be at the same, but because they're so, you know, oh, this one fell off. I guess it wasn't in. It's just loose. Let me try putting it on the other side. That's tighter, but it's still a little loose. And then this one likes to be dumb about getting the, okay. So I'm gonna hold it like this. I'm gonna try to scoop it, right? I'm gonna bring it over here. All the way down. Right, I've got a good chunk of fries here, but I can't fit it into the small cup, which I should be able to, right? So, if I can reach the bottom of the basket,
would be able to. So that's an issue that I really don't know how to get around, especially with this one. With this one, I was able to just get down there because it's thinner, right? Wonder what happens if I turn it to the side. If I like... Okay, that one's on the bottom. Now this one needs to go on the bottom. See, this is a lot of effort. This is a lot of effort, but I've got it. I just dropped one of the things. Right? And that's more than I could get with normal tongs. But I think, quite surprisingly, that I'm gonna go with this design. Because this design gives me essentially, because it's so much small, watch. It's wanting to squish the fries. Versus this one, there's much less squish and it'll even slide off of the fries. So I think I'm gonna go with this design and iterate on this one. Too bad, because I kind of liked this one more. Oh well. Yeah, I'll just iterate on this one then. Because it was a lot easier to grab them with, hang on. There. It's a lot easier to grab them on this one than with the other one. So I'm going to iterate on this design, this long design. Because I think that's good. So what I can do to improve this further is, I'm not actually sure if I still want to, that's funny, that's funny. So I'm not actually sure if I still want to make this be a different angle, right? I could make it a different angle. Right? I'm wanting to hold it like at this kind of an angle. Right? And that's, if I guesstimated, that's probably about like somewhere between 50 and 70 degrees from here to there. But it's not too bad to just hold it like this, you know? To just hold it up and down. So I'll see about that, but right now I gotta iterate on this, make it better at scooping fries. So, and I don't really think that the sharpness of this one had much to do with anything. Because if I were to get it in like this, right, I can easily scoop anything up. But just like this one. If I can get it in, I can easily scoop anything up, you know? So yeah, are there fries in here? There's fries in here, okay. So, I'm gonna take and iterate on this design, on this one, because it's easier to grab fries with this one. And because it's easier to grab fries, it's actually also easier to fit them into the fry cup, which is interesting. So yeah, what can I do? I can, of course, make this side a little shorter so that it actually does make contact on the end. I can make the topmost part skinnier than the bottommost part, right? And what that'll do is that'll give me more room here, right, to get more fries, and then it'll funnel them into a smaller fry cup, right? Because if I could fit them into here, and if I could get enough fries to fill this up entirely in one go, that would be nice, you know? And I'm starting to think that I don't actually need that, like, it's on this one because this one didn't fail. As I was saying, I don't think I need this taper here, or whatever. I don't need this geometry, this shape. So I'm gonna get rid of that. And I don't think I really need a gap here, right? There's a couple reasons for the gap in the actual fry scoop. One reason, which was me speculating, was it gives space for fries to fall away, right? And it does, right? So like if that many fries don't fit in the cup, they'll fall away, and you just move the fry scoop away, you've got a cup full of fries that's completely full of fries. But another reason is it's probably easier to manufacture that way, because there's a lot of asymmetries in it when I look at it. And so what I think that means is that there's a person in a factory bending it around a tube, which doesn't make sense to me, because like you could totally mold that, but whatever. Can you? It's got subtle curves, or it's got subtle angles on it. Maybe you can't mold it. Maybe they have to stamp out a piece of plastic with a specific shape, and then they have to fold it up. Maybe. I don't know how it's manufactured. I'm speculating here. But anyways, for this, I don't need that feature. So I'm gonna get rid of that feature. I'm gonna get rid of that angle there. That's kind of pointless. And then I'm either gonna get rid of the angle, or I'm gonna put the angle on both sides to make it ambidextrous. But yeah, I'm going with this design right here. So make this smaller somehow. Somehow make this end smaller, just enough that there's room to... Because what I need to happen is I need both ends to make contact with each other. I don't feel like picking up the one that fell, so I'm going to pretend that this is the other one. I need both ends to make contact with each other, right? But I also need both of these ends to make contact with each other, right? Like I need that to happen, and not that, essentially. How like contact here and contact here versus contact just here. I need contact on both ends. Or, you know, them to get close enough that like a fry can't get out. But yeah, I'm gonna reuse these tongs though. So I'm gonna wash these off and hang them up right there. So that's what I'm gonna do. Iterate on this design for the scoop shape, and that's what I'm gonna do.